Okay, good morning, everyone. We are starting 10:30. Please just bear with us. We are trying to get some students to join us here. So 10:30 will start. Thank you for joining.
Thanks, Tessie, for the information. Mm.
Morning, everyone. How are we all doing today?
Hello, are we ready to go? Are we good to go?
Well, I'm standing by. Somebody from SB Worry needs to share the slides because I've got a poor internet connection.
Okay, Mike. Yeah, they will share the slides. I'm just checking with the guys in the room. Okay, the slide
Right.
is up now. Yeah.
Okay, no worries. I'm standing by just like everybody else.
Good morning, everyone. Thank you
All
for
right.
coming here. Please thank you for coming here.
We can hear you.
Yes, we can hear you.
So we'll be starting right about now. Thank you everyone for joining this distinguished lecture. No cost actually resignation of our youth by my Birmingham. So to take the safety brief, I welcome Dr. Kenneth.
Good morning. SP Cleaner Energy. SP Cleaner Energy. What you going to clear that? I'll be taking the safety brief. Just to let us know that this is an accurate thing. Some of us are in the program. And so our innocent that couldn't make it because of some flight technical issues. But we're currently at the fetching all of the comprehensive the petroleum drilling institute, and this fall you have two emergency exits, one by your left, while the other one by your right. To the case there's any need for an emergency. Discussing the management of the conference center today, they looked out that will not be any form of emergency that were quite in the state environment. For those questions that are joining us online, you should take note of the emergency exits. You will be found and since an accurate meeting. For those joining online, please, it's quite good that you use your mind whenever you are not speaking. Then again, do not drive while you are on this for the advisable to the app, right? Listening to yeah, and quite the message to continue. Thank you.
What's the next agenda?
Thank you so much, Dr. Lawrence. Then we'd like to welcome our session chair for taking the remark. Please confirm that you're
Hello, confirm you can hear me. Okay. I just want to use this opportunity to welcome our beloved, distinguished lecturer, Mike Gunningham. Mike and I actually come a long way. He used to be my teacher back in the day when I joined Share. The last time I met him, I was discussing with him was like in 2003 when he was leading a particular training that every new joiner to the production technology discipline in Shell then across the globe attend. So back there in Lowenhorst in the Netherlands. So Mike is someone that is for many years has been into developing young engineers. And when it comes to production systems optimization, he is a principal technical expert. So with that background and the rich technical experience, I think he will do justice to this topic. I'm happy that a lot of students are in the room. They are young professionals as well, I'm sure. And we that are senior professionals who will benefit quite a lot from this lecture titled Low Cost, High Profit Rejuvenation of Matured Fields. Coming at a time when, as a nation, Nigeria is looking at growing our oil production. I think to support the national economy, our president has given the marching orders to companies to improve production, and we're looking at growing production in Nigeria to 2 million barrels plus per day. This particular topic is coming at a very, very crucial period of our existence. When I look at this topic, I see an opportunity for those, especially the young ones, to pick up key production driving initiatives. And then for the questions that we'll ask too, I'm sure Mike will do justice to it. On that note, I just want to welcome everyone to this distinguished lecture. Keep your hands crossed. You're going to go through a very exciting delivery. Welcome. Thank you.
Thank you, Tom. Thank you, Tommy. Yes, it was, what, over 20 years ago when you were, how shall I put it, a young,
Yes.
fresh professional.
Mike, that's about 23 years ago.
Right. Okay. So for most of you, that's probably half a lifetime. Good. Anyway, first of all, apologies to everybody that I can't be there in person, but my flight was cancelled. So I really appreciate all the efforts from SPE Warri to organize this. And Tammy and the team, I hope you can hear me clearly. I will try to speak
Loud
more
and
slowly.
clear. Yeah, loud and clear from my side.
Okay. As you can imagine, 23 years on, I'm a bit older than I used to be. So I think now I've clocked up about 40 years experience with Shell all around the world. And then later on with Maersk Oil in Qatar. And the last 8 years, I'm a consultant. And I've been working on lots of things. Tammy mentioned production optimization, well reservoir and facility management, a whole bunch of things. So at the end, you can ask me questions on pretty much anything. Shall we start the presentation then? Yeah, okay, so let's start off with the key takeaways. So I hope that all of you will find something useful in this talk. What I'm going to describe are the power of tools and processes in combination with integrated teams. Now, for all of those to work, we need to do data analytics, and nowadays you can do a lot more with data than in the old days when I was going around SPDC, where we were working from data books. Now everything is online. As far as the presentation is concerned, we're focusing on mature fields, and Nigeria has hundreds of them. You need to set up practical strategies. You need to come up with standardized processes, use the modern tools, applications available. And later on, I'm going to give a number of case studies from around the world. Typically, my experience, you can reduce operational costs by 10 or 20%. And in terms of maximizing profit, some of the activities and optimizations I'm going to talk about will give you a return on investment of 500% or more. Sometimes you can actually do something for free. Now, the way we do this is something called the value loop. And if you start at 12 o'clock with data, you always need some kind of data, but it doesn't matter what data you have available, you start with what you've got. And then if you move around to 3 o'clock, you've got the models and the analysis. If you can work with models, it will help you to do analysis and quantify what the benefits might be from an optimization. You generate a list of opportunities, you identify them with the team, and those opportunities you then need to schedule and implement. And once you've finished the job, please look back and learn so that you can feed that into the next cycle of the value loop. Now, this value loop you can do on a day-to-day basis for production system optimization. Sometimes you want to see some trends, so you look at weeks of data, so that's short-term optimization. For well reservoir and facility management, we're also looking at the reservoir, and that takes more time to react. So that's a matter of months. And using the same data, if you look at it over a number of years, typically 3 or 4 years, you might come up with a new field development plan. Next, please. So when you start the process of production optimization, your bosses are generally asking some big questions, like why is production declining? Why are costs so high? Why are wells shut in? Why is the field operated in this particular way? And if you want to change things, why can't we change things? So you can see with all of that, there's a common theme there that people accept that ultimately oil and gas fields, they will decline with time. But if you do some benchmarking, should they decline as quickly as they do? And why is it some operators, instead of seeing production decline, have seen production increase? Okay. So next slide, please. So one of the ways that we handle this, not just in Shell, but in BP and other operators have a similar technique. It's called produce the limit, where the goal is to maximize production and recovery. And quite often, you need a kickstart to this process because the normal way of doing things in any particular company generally is not the most efficient way, or not everybody is involved. So that's why the first thing we do is to get the whole team together that's working on an asset. In the office, could be subsurface people, so geologists, petrophysicists, reservoir engineers, production technologists, but also the facilities, the production people, maybe drillers and well services, but also the maintenance department and the people in the field. It's very important we get their input. And when we kick off these Produce the Limit workshops, we get management to give us some steer. What is their focus? Do they want quick barrels? Do they want longer term sustained production? Do they want to save money? Or do they want all three? And normally it's all three. Now, to kick off the whole process, we've got all these experts from a particular asset, and step by step, they paint the picture of the asset from the reservoir, through the wells, through the facilities to export. And in the process of painting the picture, they highlight what issues their particular part of the system has. And once you've identified an issue, you can then start discussing opportunities to solve that particular challenge, right? And to increase production or safeguard production if it's a risk. And what we also do is we identify the bottlenecks in the system. And you look at oil, water, and gas, because a bottleneck could be we can't handle enough water, or we don't have enough gas for gas lift, for instance. It's not just the production from the wells. So once you've been through that process, you can then capture these opportunities and you generate, and that'll be in the next slide, an opportunity bubble plot. Now, using that bubble plot, you can rank and prioritize your opportunities, capture the low-hanging fruit, so the quick wins, and also start working on the longer-term, potentially more difficult challenges. And then we wrap up the workshop by making a forward plan so that we can implement the opportunities. So every opportunity has an opportunity owner, so that after the workshop, people can go ahead and work on the challenges, work on the opportunities, work with the models, the data, in order to come up with realistic expectations and a firm plan to be implemented. And you feed that back to management so that they can help the team with additional resources. It could be additional expertise. It could be new technology. It could also be money. All right. Shall we have a look at the bubble plot now? Next slide, please. So the opportunity bubble plot is a fairly simple tool. You'll notice in the y-axis we have gains in terms of barrels per day. And because we've done this in a workshop with no engineering work, it's a ballpark estimate from the team. Now, that estimate, because it's ballpark, we use it, we put it on a log scale. And the team also estimates what an approximate cost would be to unlock that opportunity. And the time to effect is how many, how many days, months, years before you can realize the barrels. And in this particular case, the green bubbles are things that you can do yourself with your own resources. The yellow ones are the ones where you need some outside support or expertise. So you've got intelligent gas lift optimization and stimulation here. And the red ones are where you need new technology. The blue bubbles are additional surveillance opportunities, which are tied into unlocking some of your barrel opportunities. And the white bubble that we have here is for studies. And you may have to pay for a study, so you need to flag that to management. Now, the size of the bubble is your bang per buck, or the number of barrels per dollar or naira. And the bigger the bubble, that means the more economic that opportunity is. So you can see with GLO, gas lift optimization, and reducing system pressure, right, they're relatively low cost activities, which give you quite high gains. You can see for additional perforations, not quite so many barrels and significantly higher cost. So it's a smaller bubble. But you can also see in this particular case, it goes over several months, depending on your asset. I've done these kind of workshops, and sometimes we look maybe 5 years ahead because we've also got development activities that people have identified. Any questions at this stage? Otherwise, I'll continue. All right, next slide, please. Now, this is a rough estimate of the typical gains and time to effect from opportunities that I've seen, and it's a bit of a range because it depends on whether it's onshore or offshore. Depends if you have the resources in country or you have contracts with vendors to carry out this kind of work. But you can see that, yeah, the type of gains that you get, so just beating up and testing wells might be 5 or 10%. Sometimes you've got shut-in wells and you should just open them up and test them because maybe something's happened over time and they can still produce oil. You'll see the time to effect that varies. Some things you can do very quickly, some things take much longer. If you look at this list, and by the way, the Worry team has these slides, so when we're finished, they can share them with everybody who's participating today. Have a look in your particular company, in your particular asset. How quickly could you do, say, gas lift optimization or a zone change? And how does that compare with the kind of time estimate that I've put forward? Now, you'll also notice at the bottom, a reservoir saturation tool and production logging tool. Additional surveillance is particularly important in mature fields. Quite often, we have layered reservoirs and different layers have been producing, and it could be that some layers have not been perforated because at the time or the initial completion, it was thought that they were not so attractive. But maybe after 5, 10, 20 years, they still have oil left behind. So those are relatively straightforward additional perforating opportunities. And with a production logging tool, if you've got a high water cut well, quite often we have to shut those wells in. But there may be oil being produced from other layers, and it could be as a result of the production log, you can see where all the water is coming from, and if you can shut that off with a mechanical plug or with chemical treatment, then you can still produce remaining oil from that well. So there are lots of opportunities. Next slide, please. Now, I talked about the Produce the Limit workshop, which is in the middle of this table. But if you, there are lots of other types of reviews you can carry out that I've carried out over the years. I want to focus just on a couple. So the production optimization review and the well review, that's where we look at short-term optimization, wells, facilities. For the well review, it's just the wells. And if your data is up to date and easily accessible, so nowadays we have the technology to have everything either in a common server or on SharePoint, OFM. So you can look at wells on pretty much a daily basis and see what needs optimizing. If you're looking in the reservoir, a well and pattern review, especially if you have water flooding, are you getting the optimal recovery in each pattern? And later on, I've got an example of how you can do that. For the production people, loss management review, how bad is the deferment? Who are the bad actors? And what can you do to reduce deferment going forward? And then typically for the subsurface team, an integrated field review, you could do it every 6 months or every 24 months. Once you've got a bunch of new data and you can map out where you've been producing, you can then work out where the remaining oil theoretically is. And that's maybe some opportunities for sidetracks or new wells. Next slide, please. So I've got a bunch of case studies coming up now. And what I want to make clear is that you can review any field, reservoir, wells, and facilities at any time with whatever data is available and whoever is available. It's not like you need to form a team and start collecting a bunch of information. take what you've got and just get started. And you will learn as you go, and you will optimize the process as you go. Okay? There is no reason to wait until tomorrow. You can start today. And when you're looking at the data and you see something you don't understand, keep asking why. And with the integrated team, maybe somebody knows the answer, or maybe you need to get more information. Okay? And using the expertise both in the field and in the office, when you put the two together, quite often you can focus in on different scenarios and then come up with different solutions. Be creative and constructive. Work together as a team. There's no right or wrong answers. There are just opportunities. So let's have a look at the first example. Okay, so this is onshore Middle East. It's a major producer, rapidly declining production, multiple assets. They had something like 1,000 workovers a year. So one of the questions was, which ones do you do first? A massive upside, easily 100,000 barrels a day. And they had lots of data. And with that data, we had some data analysts so that we could do some root cause analysis. We could quantify what the issues were and then prioritize the solutions. So move on to the next slide. I'll give you an example of one of the things we did. So the 1,000 workovers a year. Now for that, they've got, they had 50 to 60 workover rigs. And the original plan was within about 12 months, they could do about 800 workovers with the existing resources. Now, the average gain on these wells is something like about 700 barrels a day. So it's in the Middle East. They always have much higher production than everywhere else in the world. When we had a look at the workovers, one of the things we noticed was which workovers were being done first. Right? And in terms of the ranking, we proposed that they actually looked at what the barrels per day gain is per rig day, so that you then get the quickest barrels first and you get the harder barrels later. So that resulted in a Rev 1 and a Rev 2 program. And you can see that Rev 2, we went from 700, 800 jobs. It was up to over 900 to 1,000. But again, if 900 jobs a year, that still meant 100 jobs in the year were not going to be done. So it was obvious that we needed to have more rigs if you wanted to clear the backlog. And the more rigs, okay, it costs more money. However, you get the barrels back very quickly. And for an average well, 700 barrels a day, you can actually easily do workovers and pay for extra rigs. It's very profitable. Now for Nigeria, maybe your average well is not doing 700 barrels a day, but I'm pretty sure your costs are quite low compared with the Middle East. So this should still be very profitable. The bottom line for this operator was that after 12 months, they easily had 100,000 barrels a day extra production. Next slide, please. Now, in the workover process, you need to be prepared for a workover. So we use something called Spotfire, but you can also use Power BI. We had a look at the workover readiness so that when we go to do a workover, we are ready and there are no delays, because every delay means deferring production of 700 barrels a day for a particular well. Now you can see that the petroleum engineering proposals for the first 5 jobs for each rig. So we did this for every rig, the 50 or 60 rigs. For the first 5 jobs, 60% were ready, whereas the drilling programs, almost 100% of the programs were ready. Unfortunately, that meant a lot of rework because when the petroleum engineers came up with their proposals, sometimes they had a different proposal to the program that the drillers have written, which means delays and rework. But the big bottleneck for doing workovers was location readiness. There were something like 12 different departments involved in getting locations ready, and invariably they weren't ready for when the rig was. So the rig was in transit or had to be held up until the location could be ready. So we organized a workshop for that to try and get everybody aligned. There was a process, but it wasn't very efficient because of all the different departments working together. So we needed to get some standardized processes to make it easier for everybody to get locations ready. Next slide, please. Sorry, was that a question? Tammy, your hand's up?
Yeah, I thought you wanted to go to the end before questions, but if you're ready to take my question, were around a few slides ago when you were showing the different kinds of jobs. And I was reasoning and I was saying for matured assets, most of our experience as production decline is increasing water cut and most times sand production, especially for our gas wells as well. So I was looking at water shut off as a big one, but water shut off could be mechanical or chemical, right? So the statistics you have, I don't know whether it's the chemical water shut off you're talking about or the mechanical one. Now for the chemical water shut off, it'd be nice to see statistics around success rate because obviously we're not doing much around because of the issues around candidate selection, type of chemicals that will work. And then for the sand one, you talked about the retrofit screen, the true tubing screen, when we have failure, especially if we already have a gravel pack that failed or a scorn that failed, and it becomes very difficult to do a rescon. These true tubing screens, there have been a lot of success. So just looking at those two areas, which are very key and could unlock quite a lot of oil and gas production.
Okay, I'll give you a short answer now, but maybe after the meeting we can discuss it in more detail. When you do these reviews, if you've got a specific opportunity, then do a well review and get a complete list of candidates. And it could be 10, 20, 50. And on the basis of that, you can then get a team together to work through those candidates and assess whether chemical or mechanical solution is best, and then have a campaign. And if you do a campaign, then not every job will be successful, but if you've got 10 jobs, if 8 are successful, they will pay for the 2 failures. Right? And then you will learn, and maybe the next time you do the campaign, instead of 20% failure, you only get 10% failure. So, by working in a campaign, you can build your expertise and improve the whole process for the next job. So what you'll also see is that the jobs will improve. And the through tubing sand screens, they are quite successful. Because they're filters, they will plug up with time. But if they're through tubing, you can always retrieve them, clean them, and rerun them. You'll still get more production than having a well shut in. So if you don't mind, hopefully that answers your question in the short term. We can always come back to it later if you want more.
Yeah, thanks, Mike. Yeah.
Right. So working in campaigns, here's another campaign that this particular operator was busy with. after the workovers, they needed to reconnect the flow lines, at least if it's the workover. There are 3 assets in this company. And what you see from the top right diagram is that for existing wells, the average time to reconnect the flow line, the target time was 14 days. But you can see that quite often they did it much less than that. Unfortunately, there were quite a few occasions where it took more than 14 days. And in the worst case that we found, it was over 200 days. And remember, 1 day delay is 700 barrels of oil production on average. Now, asset number 2, the middle one, this is where you've modified the flow line. So maybe you've gone from a natural producer to one that requires artificial lift, in their case, electrical submersible pumps. So yes, you need to do some work on the flow line. But again, it should only take a couple of weeks. Quite often they can do it in that time. And unfortunately, sometimes it takes a lot longer. You can see up to 147 days. So that's a modification. And then this bottom chart, that's for new wells. Okay, yeah, now you need to actually procure some materials. But a driller has managed to procure enough materials for the wells. Why couldn't the maintenance and fabrication people not get the flow lines ready in time, in parallel with when the well was being drilled? So you can see in some cases it took 200 days. Now, asset number 3 had very good performance. I'm not showing you that because they met their target of hooking up wells within 14 days for existing, modified, and new wells. So what we did was we got asset number 3 to run a knowledge sharing workshop and explain to assets 1 and 2 what they did in order to meet the target time. Okay? And as a result, we were able to get tens of thousands of barrels a day of oil earlier on production. Next slide, please. Now, one of the assets, we carried out a produce to limit exercise. Took about a week because they had a lot of fields, and we had a 2-day workshop, and then we worked with the team to convert their opportunities into a bubble plot. And first of all, notice the scale. You can see it goes up to 100,000 barrels a day. I think the best opportunity was about 30,000 barrels a day. My memory serves me correct. But you can see the biggest bubble and the quickest gains. It's still, what, 5, 6, 7,000 barrels a day for beating up wells, speeding up ESP repairs, increasing ESP runtime, so electrical submersible pumps. We also had other opportunities which took about 5 years, and that was water injection. So there wasn't a lot of water injection going on, so that was more of a development activity. But in the between, you had water and gas injection. You also had looking at deviated and horizontal wells, something that typically they were not doing, and a whole bunch of studies. So the water production, so that's where cement job study came in. Could you improve the cementing so that you don't suck up water from the aquifer? Reviewing active wells, looking at water injection, and yeah, a whole range of activities. And because everything is on the one bubble plot, as a result of that, management would then assign people, teams to work on this and make sure that there were resources available. Now, the only yellow bubble here is for long horizontal wells. The longest well that they drilled, horizontal section, was something like 1,000 meters, so 3,000 feet. And they got very good production. So the challenge was, if you drilled another 1,000 meters or 2,000 or 3,000 meters, would you get significantly more production? but for that, they needed some outside expertise. As a result of these opportunities, they're looking at what? 70,000 barrels a day over the next 5 years. So very big gains. Next slide, please. Now, in terms of saving money, I told you that a lot of the wells have got electrical submersible pumps. Quite often, they had scale and emulsion issues. And what they were doing was injecting chemicals, inhibitors at the wellhead. And they had high chemical usage because if it didn't work, you just pumped more chemicals. Now, for a scale build-up, if you inject at the wellhead, you're obviously not going to remove any scale or stop any scale forming in the well. So we put a team together to have a look at options. And the artificial lift team mentioned that, well, you could get a different type of cable with a capillary tube and then inject the chemicals downhole at the pump inlet. Now that significantly reduces your chemical costs because then, especially with emulsions, if you can inject the demulsifier before the emulsion forms, it's much more effective. And for the scale, if you can stop the scale forming inside the tubing, that saves you having to do any remedial tubing cleaning or flow line cleaning. So that would save hundreds of thousands, if not millions, of dollars per year, and you've got hundreds of barrels a day of extra oil. Next slide, please. Now we're going to move from onshore to offshore. This is in the Asia Pacific region, independent producer. How shall I put it? Much smaller scale. They only had 4 fields with low production, about 5,000 barrels a day of oil for all 4 fields together. This time the wells were gas lifted and which they needed optimization. It is offshore. It's an old field, so costs have to be low. The models were out of date, and they had a bunch of engineers in the head office, and then they also had a production team in the field office. And in those days, this was before COVID, the only way to sort of discuss things was to actually go from the head office to field office or the other way around, because they did everything face to face. So next slide, please. So we started with the gas lift optimization. In theory, that's something which you can do more quickly. We came up, in fact, for the gas lift review, not only did we have the subsurface team, but we also had production team, we had a production optimization team from the field, and also some engineers, some facility and process engineers, and rotating equipment specialists. From our side, as consultants, we brought some expertise along to look at the models and bring them up to date so that we could quantify the gains. And we did a reality check with both teams to see if the gains that were predicted were realistic and doable. And then we fed that back to management. So out of the 5,000 barrels a day that they were producing, the estimate was that we could get an extra 1,000 barrels a day, half of which was probably in the first couple of months with bean-ups, reducing system pressure, reallocating lift gas on the basis of models, and increasing the gas-oil ratio limit, in which case, if you allow those wells to produce, then you don't need so much lift gas for those wells, and it can be redistributed to other wells where you get a better benefit. Now, in order to improve things longer term, we noticed that the compressor uptime, they had 7 old compressors. The uptime was typically around about 80%. And if you could get the uptime up to 95%, you had more gas available, so you'd get more oil. So that's improving the compressor uptime. Longer term, you could actually look at replacing the compressors. Right, so instead of 7, just have a couple, but modern machines which are more reliable. Install a vapor recovery unit so that you've got extra gas available, and you can reduce the system pressure on the jackets. You see all of those contribute hundreds of barrels a day. Does it involve some investment, but the return on investment is significant. Next slide, please. So after we had done the gas lift optimization, in the meantime, we were able to start building well books for each well in the field. I think there's about 150 wells in total. And so this was back in 2018. What we did was we then introduced the company to, I think we used Teams or Zoom to get everybody together, and we sat for I think 3 or 4 days systematically going through every well in the field. We updated the well books so that we had the latest information. We had the 2 locations in the review, so we got input from the field and from the office. We also made a surveillance plan, so you'll see on the opportunity bubble plot there are some surveillance activities in blue. And again, because we had both sides together, the field and the head office, there's a reality check in terms of the potential size of the gains, the costs, the doability, and the timing. And in this particular case, you can see that we had gains in the region of 2,000 barrels a day in 12 months. And you'll notice that at the 12-month mark, we got some tubing changeouts and some sidetracks. So they needed 12 months to get a rig available. We had a geologist and a reservoir engineer working on this, and they looked at the remaining oil and where it was. So we found that there are quite a few shut-in wells where if you sidetrack them, you could tap into sweet spots with remaining oil. So that was a big bonus. Next slide, please. Now, we've moved back to the west. So we're in North Africa now, onshore with a major producer. And this particular operator had field 150 wells and a lot of ESP failures, about 50 wells per year. So a third of the wells, the ESPs failed in that year and had to be replaced. Now that cost $25 million per year, but it took 30 days for those jobs to be carried out and production to be restored. And in the meantime, you've lost $75 million worth of production per year. So the total cost of the ESP failures is around about 100 million a year. Now, there are multiple causes for the ESP failure. Talking to the team, they suspected that using old ESPs was probably the main problem. In North Africa, rather than getting new ESPs for each well, quite often they'll refurbish the old ones. And that's not always a good idea, especially if you do it in a hurry and you don't have the spare parts. We had a look at the ESP failure statistics and determine what's required and quantify which elements cause the highest failures. Quite often it was an electrical issue, sometimes cable, and sometimes it's just the bearings wearing out. We also noticed that some ESPs ran for several years without a problem. Why was that? The solution should be on the next slide, please. So we got them to form an integrated team. looking at root cause analysis for ESP failures over the last 3 years. Once you understand the root cause, you can then offer solutions, and you can rank and prioritize those solutions and reduce the costs of ESP failure. But in the process of doing that, because you're going into these wells, you can also do some well and reservoir surveillance. You can do other rigorous activities, so water shutoffs, maybe some stimulations, some perforations. You're doing workovers, so maybe you can clean up sand issues, for instance, or you can decide, because you've got the rig there, maybe it's better to sidetrack a well, or even do some infill drilling. And for that, we put together an opportunity plot, which is the next slide, please. So again, here you can see we go up to, say, 1,000, 10,000 barrels a day. So very good opportunities. And the biggest bubble is always opening up the chokes. So they've got electrical submersible pumps, and they were still choking back production. Not the best solution. Stimulations, they didn't do stimulations because they didn't really have the expertise. So especially if you're doing workovers, then there's an opportunity to go in and do some stimulations and shutoffs. So you've got the shutoffs, and I talked about the additional or reperforations. There's a whole bunch of surveillance opportunities, flowing build-up surveys, production logging tools, reservoir saturation tool, and just opening up closed-in wells. So similar to Tammy's question, water shutoff, that was quite prominent. So we were doing this, I think, in 2021. So that's where the 2022, 2023, and 2025 comes in. So there was a whole program of work for 5-year period. Lots of opportunities, and I suspect a lot of these could be taken over by all of you in Borry. Next slide, please. So this is my last case study. This is offshore Middle East, independent producer looking at well, reservoir, and facility management. Now you're probably looking at the picture on the right. This operator had very long horizontal wells, average length 20 to 30,000 feet, so up to, say, 10 kilometers horizontal. And they'd implemented water flooding. So each of these patterns that you see, on the outside, there are 2 injectors, and on the inside, there is 1 producer, and that is a pattern. And in this case, we're looking at absolute voidage. And if the voidage is bad, it's red or dark red. And if the voidage is good, then it's green or dark green. Now, we can make these patterns. We did this in OFM, and we looked at the voidage per pattern, the replacement ratio, the pressure response. We looked at water cut. We looked at gas oil ratio. You can do all of this per pattern. And what this allows you to do, and this was 1 reservoir, we had 3 reservoirs where we were doing this. You can then focus on the dark red or red patterns and say, okay, why are they underperforming? What do we need to do to fix? And typically what we found was the red patterns were failing because there was a tubing failure in one of the injectors. So they couldn't get enough water down into that pattern. And what we noticed was, in the end, we identified 30 tubing failures, and the root cause was that they had corroded because of bacterial corrosion, microbial bacterial corrosion. So not only did we have to do a bunch of workovers, but we also had to look at chemically treating the injectors to make sure that we didn't get any further corrosion there. We also looked at souring, make sure that we weren't souring the reservoir. The good and bad areas. Also, there are some areas which were dark green, so we were probably over injecting in those areas, so you can then take some water out and put it into other patterns. This particular field was producing 300,000 barrels a day of oil and producing a similar amount of water, and we were injecting 1 million barrels a day of water. So for 10 barrels of water, typically you got 1 to 2 barrels of oil in 6 months. So once we explained this to the operators offshore, they fixed the water injection system as quickly as they would fix anything on the production system. The result of all of this is we had gains in the region of 30,000 barrels of oil a day. So next slide, please. So to conclude with, and this is my last slide, rejuvenation of mature oil and gas fields is hard work. There's a lot of data, a lot of people. You need to collect the knowledge and the data, use the value loop to be systematic and consistent so that you can identify and prioritize opportunities and effectively look at the barrels per dollar or barrels per rig day if it was workovers. You do need to spend money to make money, and there's always more to optimize. So for all you students out there, this is a job for life because you never stop optimizing. So with that, I want to thank all of you for listening. The next slide, please, because the SPE Distinguished Lecturer Program, we would really like your feedback. So next slide, please. Yeah, so questions. There is a QR code on the SPE website where you can give feedback about what you heard today. We welcome the feedback. I get it, and then I can always improve for the next time. So who wants to start with questions?
We'll hand back to the moderator in the room. Confirm you're there.
Yes, yes. So then the question regarding the transparency, and then
We can't hear you very well online. Can you use the mic or increase the mic volume?
please confirm can hear me clearly now.
Maybe someone can repeat the question directly to the computer, right? So I understand you need to use the microphone for the room. Any questions?
We're struggling to hear the room. So we'll just wait for them to get back to us.
Okay, the other thing you can do is type the questions in the chat box, and Tammy and I can keep an eye on that. Got me, Tammy?
Yeah.
Good morning.
Morning.
Thanks for the presentation. It was quite probably also a lot of experience in this thank you for sharing those data and success story. But the cost is
Sorry, can you guys in the room, can you hear me? The volume online, we can't hear you very well. It's not audible enough. Can you drop questions on the chat box?
The network is. The network is unstable here.
Hello.
We can hear, but there is an echo now. Echoing.
Yeah. Maybe
if
you
you're in
can
the
ask
room-
your question directly
Yeah.
to the computer, right, rather than standing on stage.
Yeah, now.
Yeah, keep going.
Yes.
Okay, so I said I was looking at your costs. What's the cost?
Yes, the plots.
In some of these things, what's like the cost in terms of the revenue?
About two different.
Is it that someone was spent? What's the cost of the revenue? Then again, in the modified UTP, what is the impact on the UTP and the modified unit technical cost based on the rejuvenation strategies? Thank you.
Because
Right, so let's just have a look. Do we have the question in the chat, I believe? Right, so what's the key economic drivers and challenges? Was that the question that you had?
Mike, I think he was asking the pause. I guess it's possibility of success for each of them.
Yeah, the possibility or probability of success. That's
Yeah.
always a tricky one. If you do it in a campaign, 10 jobs, I think you'll find you easily get 70, 80, 90% chance of success. There will be some operational failures. There's also, a job can be a technical success, but maybe you didn't get the gains that you predicted. On the other hand, that's compensated by the better than expected gains where you've been a bit conservative. But if you work in a campaign mode, you put a good plan together and then you follow it through. I think you can get 80% operational success, and the barrels might be 50% of what you expect, might be 100%, might even be 150%, because sometimes we're very conservative with our estimates. It will vary from the type of job that you do and the number of jobs. The more jobs you do, generally, there's a higher chance of success. Don't be surprised if in the first few jobs, there is a failure for one reason or another. Does that answer that question?
Yes, thank you, sir.
Good.
So
Right,
there's another question on the chat box. That question says,
Do we have another?
what are the key economic drivers and challenges in the rejuvenation of matured fields? Economic drivers and challenges in rejuvenation of matured fields.
Okay, so the economic drivers, the first and foremost is what's it going to cost? Yeah. What's it going to cost? Because that's something which you can influence. The price of oil, for a lot of people, they would say that's an economic driver, but we as engineers have no influence on the price of oil. The only thing we can do is maximize the oil production every day, and try and do that at the lowest practical cost. Now, having said that, if we're going to do well interventions or workovers, then they need to be economic. But quite often, these kind of jobs will pay back inside of a few weeks or a few months, right, depending on your oil production. Right? So you can use that to a certain extent for your selection criteria, but the probability of success is very important. So doing easy jobs where you're quite sure you're going to get the gains, you always want to do those first. So whether you call that an economic criteria, it's effectively the probability of success. So you want to get successes under your belt. So do the easier jobs first. And typically the easier jobs can be done more quickly anyway. Anything which is a bit more complicated, you need to do some planning.
Okay,
Does that
clear.
answer the question?
Yeah, I think it answers the question. But back in the room, confirm that those guys in the room, you can still hear us.
Yes, we
Hello?
can hear you.
Yes, we
Okay.
can hear you loud and
Okay.
clear.
Mike,
Right.
the next question on the chat box says that how can data analytics help rejuvenation of matured fields?
Yes.
Say,
Data
how can,
analytics.
yeah,
How? All
can, yeah.
Right. So data analytics, it sounds a little bit straightforward. You need to analyze your data, and nowadays we have tools. First of all, put the data in a database rather than an Excel sheet, because the problem with an Excel sheet is it breaks down, and once you have too much data, if you get an error, then you are lost. Whereas with a database, you can keep adding the information, and then using tools like Spotfire and Power BI, they can analyze the data, and they can filter it so that you can do cross plots between, say, production and what kind of well, what kind of reservoir. You can look at high water cut wells, high GOR wells. You can have a look at which wells are producing and not producing, and coupled with the database, you can then map those that data on a reservoir map, so you can see where your good production is and where your poor production is across the field and across the different reservoirs. So vertically, but also aerially. Now, once you've done that, as an engineer, you just keep asking some questions. Right? Why is one area producing better than another? What kind of production decline rates do we have? Are they the same across the whole field, or is production declining more in one area than another area? You can also, together with the well data, look at artificial lift and compare, let's say, what the injected gas lift ratio is compared with the liquid production, and see if you can optimize your system that way. So there are lots of things that you can do with data analytics, or lots of questions you can ask, and data analytics will help to give you some answers so that you can zoom in and focus on specific areas, challenges across the field. And different, you may have different issues with different well types. So if you've also done some water analysis, what kind of water salinities are you getting? If you've got sand issues, is sand coming from a particular layer, particular reservoir, or is it widespread across the whole field? So mapping all of those issues, you can then start to understand what the problem is, what's the root cause, and how can you fix it.
That's very clear. Back to the room. Can you guys hear us still? Okay. There is a comment, Mike, from the
Yep.
room. They say, thank you very much, sir, for your answer. It's well understood. And I think it was the other question. And it says, his summary is that do the easier job first. So that's what he's taking away. And this other one
Yeah.
says, thank you so much. It was a very insightful answer. A follow-up question for you, Mike. I think this is
Yep.
from me, is the fact
Okay.
that these days there are quite a lot of non-technical risk why we do not realize the barrel. The engineer
Yep.
have done all the work, but
Mm-hmm.
you have other non-technical reasons, flow line theft, and even
Yep.
code theft. So in this WRFM world, are there tools that will help us with surveillance activities around the flow lines and other equipment such that we can react fast? I take an example. In one of the fields examples that you gave, they saw their pumps, they understand their mean time to failure.
Yep.
And it took them 30 days to restore the pumps back. And for those
Yep.
30 days, we're looking at how much we're losing. So
Yes.
if we're able to respond with flow line and well equipment theft very fast, we reduce the deferment that we incur by
Yep.
the long time of absences. Are there tools from experience that can really help in this regard?
Yes. So one of the first things is a well flowing or not flowing? So I think if you have problems with flow line theft, can you at least at the flow station check that the well is still flowing? And if it's not flowing, then is it flow line theft, or is there actually a problem in the well? Is there a problem with the artificial lift technique? So you can do this quite easily with nodding donkeys, circle rod pumps, and also with electrical submersible pumps. They can actually send a signal out that they are operating correctly. So you can use those kind of tools to see if the pumps are working in the wells, but you can also check with just a flow indicator if a well is flowing. You might not be able to afford an inline flow meter to see how much it's flowing, but at least you can see if it is flowing. Some of us old-fashioned people, we would actually go to the flow line, just put our hands on the flow line. If it's warm, it's probably still flowing. If it's cold, it's not flowing. So it's maybe something the operators can do just as a quick check. Maybe that they're already doing that. The thing is nowadays there's also lots of new sort of mobile phone devices where you can send signals from remote locations to your gathering center, your production station. The only thing is, of course, they cost money and they could also be stolen. But on the other hand, if you've got something like that set up, maybe you can have a little CCTV on the location as well, so that you can see what's going on, and that gives you some warning. And in some areas of the world, that's what they're doing. And they have, how should I put it, a security company that goes around for quick response.
Yeah, indeed. And I think the security company bit is what in the Niger Delta is actually helping with our uptime of our lines now. So that bit is really good. I think even this your answer somehow covers the next question someone asked. It says, which engineering innovations are driving the profitable redevelopment of aging petroleum fields? I don't know if you have any other thing to add, Mike.
there are lots of things going on. I think nowadays there's a solution for almost every particular problem. The question is it readily available here in Nigeria, here in Warri, or do you need to get somebody to bring it into the country? The new technology, I mean, you can go right across the whole system. If you look at the wells and the reservoirs, if you can afford it, having downhole pressures, you've got distributed temperature sensors, which might help you with analyzing what's going on. You can, by the way, the distributed temperature sensor or distributed acoustic sensor can also be used instead of a production logging tool. So if you actually run the cable down across the perforated interval, you can actually see what's being produced. And these are disposable fiber optic cables. You just drop something down a well, it unspools, and the weight at the end drops to the bottom. You can then see what the holdup depth is, and then you monitor the fiber optic signal for as long as you want. And then when you're finished, you just snap the cable, it drops down the well, and literally the amount of fiber optic cable is only about this big, and it will just disintegrate. So that's something very unusual. It's not something I've seen very often, but that kind of technology exists. Something which is maybe more prominent are different types of chemicals, and there are now better chemicals available which you can apply with a lower dosage. The only thing is these specialist chemicals are more expensive per liter, but because you use a lot less of them, they are much less expensive than conventional chemicals. So overall, your cost of chemicals can go down significantly. And it's very important for your production chemist to independently assess which system gives you the best performance. Typically, when a problem occurs on a chemicals, the vendor will always say, apply more chemical. Whereas the practical solution is actually to look at what you're doing, and maybe less chemicals is better. Right? And if you can apply them down hole, so next time you do a workover, can you run a control line, a hydraulic line down to the bottom of the well and inject the chemicals down hole rather than at surface, like I explained with the electrical submersible pump. And we already talked about the sort of the Wi-Fi, 4G, 5G monitoring techniques from remote locations. That's also a safety issue. It means people are driving less kilometers, so your transport risk is significantly reduced, and you get more up-to-date information. And that technology is coming down in terms of cost. I don't know how many people in Nigeria actually have video cams on their doorbells to see who's ringing the door. Right? And then you can effectively see who's ringing at your door when you're at work. And that type of technology might also be useful in the oil field. As far as I mean, I could go on and on. I mean, the Venturi gas lift valves, that's something for gas lift completions, putting extra sensors on your electrical submersible pumps and your sucker rods for improved pump performance, making sure you stay in the operating envelope. There are lots of things you can do.
Indeed, other questions are coming in, Mike. I'll read them to you.
Yep, please.
Well, while I'm going there, indeed, a lot of gas fields in Nigeria, we use sub pumps and gas lift. Soccer rod pumps are not very common in Nigeria.
Okay.
Okay. This person says, I think this is Prosper Eze, says, "Thank you very much, sir, for the presentation. I have a
Mhm.
question. Please, in your conclusion, one of your points was spend money to make money. How does
Yes.
this apply in this phenomena? Thank you, sir."
Okay. Any well intervention is going to cost money. Uh, and in the past, quite often, we've done these jobs on a case-by-case basis, which means we've had high mobilization costs, and yeah, the jobs can be quite expensive. When you start working in a campaign, and let's say you're doing some additional perforations, if you've got one truck which is doing 10 jobs, you mobilize it once and it goes from one location to the next, hopefully reasonably close together. And because you've ordered guns for 10 jobs, you can generally get a better price. But more importantly, the chance of job success increases because you're looking at how you do the jobs, which intervals you're perforating, and you can learn from one job to the next rather than waiting a few months. So in that respect, yeah, you're then paying for 10 jobs, but probably you're saving quite a bit of money because you get a bulk discount. And the return on your investment, you will probably have a payback time of a few weeks for perforating jobs. So the fact that you've actually had to spend money, yes, you earned it back relatively quickly. So that's what I mean about spending money, right? If your management is in cost-cutting mode, then you can suggest to them that they just shut in the field, and then that solves the costs, doesn't it? But if they
Yeah,
want
indeed,
to,
Mike. And also, I'm thinking in the direction of the data surveillance activities that require a lot of money as well. For example, I want to do a
Yep.
reperforation job.
Yep.
I need to
Mhm.
know where the current contact is. So running a saturation log tool
Yep.
is very important, because if I don't
Yep.
do that and I go and perforate water or undesired fluid, that's not value. So you indeed have to spend money in acquiring bottom hole pressure surveys through wireline most times, where you don't have
Yep.
permanent downhole gauges, or you
Mhm.
spend money to put permanent downhole gauges, like you said, so that you can
Yep.
take pressures and measurements.
Mhm.
So in that regard, you spend money to make more money. Thanks for that.
Yep.
There is another question on here, and it says that what is the best production method to apply in the low-cost, high-profile rejuvenation in mature field? Is it a single string, dual string, or multiple production method? Mike, I guess this one is talking about the type of completion, whether you
Yeah.
do a single string, single string dual, or a single string,
Yeah.
multiple string,
Yeah.
or a dual
Assuming,
string.
yeah, assuming you are allowed to co-mingle, then the single string completion is generally the cheapest option. But you do need to have a look at what the different layers are doing. Are they at similar pressure? Are they all producing the same amount of oil? What's the volume per layer? So you can imagine that a small layer will deplete more quickly, and maybe it will start producing water. Right. So when you're designing your completion, please think about the life cycle. And if, for instance, one zone waters out or depletes very quickly, do you have a way of closing that zone off? In which case you might want a multi-zone completion. Again, assuming that you're allowed to co-mingle. Generally speaking, in the old days, we had dual completions because the authorities told us we had to prove what we're producing from each layer. I think nowadays with PLTs, we can convince people that we know what's being produced from different layers, but it does mean we need to have PLTs on a regular basis. So that's one thing. Another thing is, if you have a multi-zone completion, then you can either produce or you can shut in. If you want to control the flow, then you need an inflow control device, a downhole choke, which you can adjust. Right? So you could spend the money and have a smart completion, right? Or you have a slightly dumber version where you can just shift a sleeve to open and close a zone. And that then covers you in case you end up producing 100% water from some layers. So you always look at it case by case basis. The subsurface team need to work together with well services and drilling to come up with an optimum solution for each particular case.
Thanks, Mike. Also to add that if you have enough money, you could put downhole flow meters to convince the regulators what each zone is doing. And then the geochemical fingerprint is something else that have come to help with production allocation.
Right.
There's another question that says, how can operators balance the need for cost efficiency with the requirement to ensure safe and environmentally sustainable rejuvenation projects? Mike, did you get that?
Yeah. No, what was the beginning bit? How do you
How
safe
can
and
operators
sustainable?
balance the need for cost efficiency with the required environmental safety requirements for a rejuvenation project?
Okay, so obviously anything we do has to be safe, right? And nowadays, the environmental side of things, we try to use environmentally compatible equipment. In Europe, for instance, nowadays we try and use electrical equipment rather than diesel driven. So that's something to look at if you have a power source available. But the big environmental impact is, do you do a job or not? And if you can avoid using a rig and do something rigless, it's not only more cost effective, but it also reduces your environmental footprint. And nowadays there are lots of smart things which you can run on wireline rather than electric line, which you can then do through tubing and expand below the tubing into the liner casing. So that gives you options which maybe weren't available before. And in the past, you might have had to do a workover, pull the tubing, and then work on the production interval.
Thanks, Michael. There is another question. Moderator, I don't know how much time we have, but you can stop me when we're there. This person is thanking
If you can hear me, let's take one more question, sir.
Right. I'm not hearing anything. Did we lose our speaker?
Can you hear me, sir?
Yes, I can hear you. Yes.
Yeah.
Okay.
Let's take one more question, sir.
Okay, go ahead. Okay, so I should take one more question. I was booted out by Zoom. Okay. So okay. I was booted out by Zoom, so I lost the questions online. You can read the last one, so I couldn't, get it again. So please help us read.
Okay, let me take the question from Tita. So Tita said, I served as a tracer field engineer from Glotec Marine, Cameroon. We specialize in helping oil and gas operators maximize production efficiency through chemical tracer technology, a cost-effective, accurate, and non-intrusive solution for reservoir and well performance monitoring. I'm truly excited to be part of this webinar today, especially hearing Mr. Mike share insights on low-cost, high-profile rejuvenation strategies for mature fields. So this is not a question. So let me look for one question.
Recording in progress.
Okay, Olajide.
Tony, we lost your connection. Are you still with us?
Okay, yes. Olajide is asking how can we maximize value creation?
Mike, confirm you can hear?
Oh, sorry. Yes. Yeah. I was. Yeah. Didn't want
Yeah,
to interrupt anybody.
yeah,
Yeah, I
how
can hear
do
you
you-
clearly.
Yeah, how do we maximize value creation? I think that's the last question.
How do you do all of the above? So with that, if the worry section can take my slides, make a PDF, and send it to everybody who's attended. What you can do, let's see if this works. You can always email me with additional questions.
All right.
Okay. All right. So my email, I'm just typing it in now. But quite frankly, you start by just getting people together, getting your data together, and focus on a number of wells or an area of the field which you have a concern about, and just start working it. And then on the basis of that, you can then expand as you get more experience and more resources. Everything I've given you is a toolbox for how you can do optimization. Right? If you need some extra help, my email is now in the chat box. Right? When the worry section sends out the PDF of the slides, if you can add my email address, you're all welcome to contact me. Right? And I'm still busy doing optimization. I still work, and that hopefully goes to show all you youngsters that there is still a future, not only in oil and gas, but moving forward. I work on a carbon capture and storage project at the moment because I'm in Europe. So there are lots of other opportunities, but I think in Nigeria, yes, keep the oil and gas flowing, and moving from oil to gas will help to reduce the environmental footprint, and optimizing what you have, maximizing recovery. You've already spent billions of dollars drilling wells, building facilities, pipelines, LNG plants. Build on that. There is still more oil in the ground in Nigeria than what you have produced so far. So all of you have a long-term future. And then once you've, for instance, depleted your gas fields, you can then start looking at collecting your CO2 and injecting it underground. And that will reduce your environmental footprint going forward.
Thank you very much, Mike. Just checking. There's someone that says, I actually raised my hand.
All right.
So, yeah, you raised your hand. You want to speak before we close?
Yes, good afternoon. Good afternoon, everyone.
Afternoon.
Good afternoon.
Thank you very much. Yes, thank you so much, Mr. Mike, for the excellent presentation. I already introduced myself. I'm speaking from Cameroon, SPA Cameroon section. I'm excited to be part of this presentation, and I've learned a lot from the presentation. I just wanted to ask this question, talking about do the easier jobs first.
Mhm.
When you talk about doing the easier jobs first, are you talking about considering the cost also, or just talking about the technical aspects of the job? And my second question is, I know there are a lot of students who are listening to us right now. So what are the key uh, takeaways that you could give students who are looking forward to working in these areas of rejuvenating the oil and gas mature fields? Or what technical skills should they be looking at building, those who are actually interested in this direction? Thank you so much.
Okay, thank you, Ava. So the easiest jobs, literally the easiest job you can do is open up a choke. And you would be surprised how many wells are choked back. You can then look at the system operating pressure, look at pressure drops throughout the system. How can you minimize those pressure drops? Because that back pressure is all working on the well and reducing your production. So those are the cheapest and easiest jobs you can do. You do need to check with the production people. Why have they been back wells? Is it because of sand production, whatever? And then you start looking at levels of complexity. So, yeah, what's the next easiest thing you can do? Is it doing interventions with slick line? Maybe some coiled tubing work, doing some stimulations, some additional perforations, some water shutoffs. So look at the sort of technical complexity. And generally, the easier it is to do, it's probably cheaper as well. And it could well be that maybe you need to do some monitoring surveillance downhole before you actually try and get some extra barrels. And that will increase the chance of success whenever you do, say, additional perforation stimulation or water shutoffs. So that's the way to start. You can still do workovers. They're more complex, they're more risky, they're more expensive. Now, as far as the students are concerned, this is very important. You have the luxury that I didn't have 40 years ago, that nowadays, I won't say everything's on the internet, but everything is at your fingertips on the computer. So you can be very powerful, very constructive, very early on in your careers. I think most universities are now have a data analytics module as part of their course. And using data analytics will help you to rationalize your data and look for trends, find root cause analysis for problems, which will then help you with solutions. And it's very important when you start, buddy up with the more experienced people and tap into their experience and their knowledge, things which are not on the internet. So what works and what doesn't work in those particular fields. And a combination of youthful enthusiasm and, how shall I put, some rational, mature experience works extremely well, in my opinion, in terms of optimizing production.
Thank you so much, Mr. Mike.
You're very welcome.
So, Tony, is there any other one? Any other question, or are we out of time?
No.
Confirm
Can you
if
hear me,
I
sir?
Yeah.
Yeah, we won't be taking any other question.
Okay. So
Yes, for
let's
those
go to the
listening,
next item on the agenda. Yeah, see, on those of us that are online, I see a message from Kristen. If you drop your email address, we can send you the presentation materials. And
Yeah.
we already have Mike's address, email address. You can send him additional questions when you look at the presentation materials. Dr. Daytona, confirm you're in the room. We'll go to the vote of
Yes, I
thanks.
can hear you.
Okay. Next.
Darren, shall we go back to the room so that they can
Yeah,
wrap up?
yeah. I'm asking the room if they can hear us and what's the next. Confirm you guys, as if you guys are speaking, we cannot hear you.
Okay.
Yeah, I think somebody said something now.
Yeah, it's echoed and I didn't hear.
Mhm.
Hello, section.
Yeah, you're echoing, we can't hear you, but I don't know if this is the part where you doing the vote of thanks or any presentation. This is really bad. The audio. Back in the lecture room, we cannot hear you. Can you speak to one of the computers?
Hello, can you hear us now?
Yes, we can hear you
Yes.
now. Thank you.
I was muted. Even when the other people echo,
Dr. Daytona, we can hear you now.
Section 12 for a good online moderation work. You have done very lovely work. I'm sure Mike will be surprised the way you're able to handle the online section. At this point, I would like to call on Dr. Ogolo to come and give a little aperture on the presentation that we've done excellently by Mike. Thank you so much for a wonderful presentation. We were hoping we were going to have you physically here, but things turned out the other way around. The students are happy, they are excited, and some of them are not even realizing the optimization is not just the beginning part of the life of the world. It's something you have to plan along with your healthy. So we appreciate you, Dr. Roman, please kindly give us a little aperture on the presentation. Thank you.
Thanks once again to so indeed, it's very enlightening. Like I said, thanks for speaking to us the low-cost, high-profit rejuvenation of mature fields. And I think this topic is very apt, especially in the Nigerian environment today, where we are looking at boosting our oil production to about 4 million barrels of oil per day. And one thing that I enjoyed the presentation is that you really leverage on your extensive experience to drive the subject matter. So, to see case studies of where rejuvenation work was applied. We saw data, we saw records, we saw values, the impact of well and feed rejuvenation. And we also like your approach, which you stated, by not just moving your team to anything, but rather you have a strategy. And some of them involve growing up the opportunity for growth to identify potential opportunities that would lead to better oil production. And they also use the concept of opportunity training. And for young professionals and students, you can also see that doing some technical jobs, you don't just go to the field just like the provider, go to frame up what the opportunities and try to identify what strategy can be used. And also through the presentation was really enriched with compelling case studies. And particularly we saw data where you equate production by 20%, and some cost savings was also some cost savings approach. Some were in terms of millions of dollars annually. And the case where we saw the ESP that was used in a certain field. And we saw that because of the strategy that they applied, that they spent about $100 million annually through the process of distribution of such field. That amount was reduced. I think the company were so happy to see that those kind of money is no longer lost due to ESP issues. And there were other cases where we saw that 30,000 barrels of oil per day was equivalent in terms of this amount. So thank you once again for a more industry engaging lecture. Thank you.
Thank you all for having me. And hopefully next time I can see you all in person.
Mike, you enjoyed the little reflection you are giving about your presentation. However, there's somebody on the call, all the way from Port Harcourt, is one of the section directors from Port Harcourt. That's Engineer Usman. We'd like to appreciate you for being on this call with us. What SP family is all about. Even though the BL lecture is for section 104, it's still took his time out. Engineer Usman, we don't know if you want to say anything to our guest speaker. Engineer Usman. Can you straight him out? Mohammed Usman, okay, I guess he has left the call. He was on the call not too long ago. Anyway, at this point, we'd like to thank everybody, both those online, those that are physically present. For those online, engineering, thank you. Dr. Augustine Luciano, we thank you, Professor Juliet, thank you for still making. Of course, our whole section chair is still online. We thank you for the time out. Please can you go down there? I see some people. I've seen a lot of white people from Carrington. Please, can you go up? Can you go up, please? Thank you. Okay. Engineer Chris. Yeah, Dr. Nixon Bond, thank you for joining the call. Engineer Chris Boatu, thank you for being on the call too. Thank you everybody that physically came. Students of NMU, Nigerian Maritime University, thank you for being around. And also, Federal University of Petroleum Resources, thank you for taking your time to be at this event today. The time was closed, early morning presentation. And also from my own constituency here, that's Petroleum Training Institute. I would like to thank the students, members that took their time, the lecturer, engineer, Shewa Abubakar, also a board member that made it to the event. Thank you all for taking your time. And of course, without my support, our amiable section admin will be here from 7:30 in the morning to ensure everything goes smoothly. We say a big thank you for your time, your dedication. And for Mike, we want to wish you a safe trip back. A lot of we missed being around you today. And we are going to do something. We don't know how we're going to get it to you. We have your award here, so we are going to Dr. Guluben.
Let's see the plaque for Mike. Let's see the plaque for Mike, so that we can now look for a way of handing over.
Engineer Show, can you come over with Dr. Ogolo? Please come. On behalf
Mike,
of
we have a little token for you. Unfortunately, you were not there. We have to look for a way to hand it over to you.
You are ready to be carrying this all the way back to home to show your family that, oh, you are well appreciated and worry, because worry is always part of you. You've been here before. We are hoping for you to step your feet on the worry story again. God has done better plans, and we are happy you are doing fine later. So at this point,
Dr. Letona, the camera is by your left. The camera is by your left. So turn to your left, yeah. Yes, yes,
All
yes.
Yeah. All right.
So on behalf of Section 4, we would like to present this to you. Engineer Shehu, please receive it on behalf of come to my front. With your
All right.
Yes. So let's raise it up for him to see his award. Thank you. This is your award.
Thank you very much. It looks fantastic. Next time I'm passing through Warri, I'll pick it up.
Okay, thank you.
So at this point, Secretary Chair, we want you to say the closing prayer because we are already done. And so we want to take the photograph section now. All the student chapters are available. Please come to the front. Let's take. But before we do that, if you're online, please turn your camera on. Everybody online, and don't forget SPE. You say cleaner energy, and we'll take the snap from here. So everybody online, can we be all of our cameras and videos or you know what to do from them. Are we ready? Thank you, everybody. I'm seeing their fine faces. Are we ready? I think so. Are you ready? Yes. SPE. Can we take this shot? Can we see the number for SPE? SPE. Energy. All right. Thank you so much.
Okay.
Okay, so we want to take the physical photograph, right?
Thanks so much, Mike. I
No,
wish
thank
you
you.
a trip back. Really, really
Thank
nice to see you again.
Good to see all of you as well.
Thank you.
All right, so thank you. That's the end of the meeting session. We hope to see Mike Monday very soon, maybe next year or whenever God gives us the opportunity. So at this point, let me say thank you so much. We wish you a back home. Thank you.
Don't go off now.
Thank you.
I'm still taking the names of their emails.
Okay.
You are taking it. They will send it to you.
Yeah, thank you, Mike. We are grateful to have you, and it was an excellent presentation. We appreciate
Thank you very much.
Yeah,
Thank
you are-
you.
Thank
No, I really appreciate all of you. I mean, how many people were in the room?
Yeah, we had almost 40 persons in the room. So over some period, some were leaving and some were joining, probably network comings.
Okay. All right,
Yeah.
and then what, another 20 people online, I think. Yeah, so
We had more than 20 online. You know,
Yeah.
based on network, some were coming in and going. There was a time we had almost 39 online.
yeah, okay, all right.
Yeah.
Well, I was impressed with the fact that I managed to stay online. So obviously the Nigerian internet system, at least for me, worked extremely well. So,
Wow. That was a plus, and we appreciate that. It was great indeed.
yeah, no, I mean, from my point of view, it's great to see so many enthusiastic people, lots of questions. I saw in the chat box there was a transcript. So if you can send that to me, if there's any questions I missed, I can always drop the SB Worry section an email with some additional information, right? Or those people just need to drop me an email with their questions.
Noted, sir. So we'll get the transcript from the session and we'll forward it to you. You'll see all the questions that came up during the session.
Yeah. Very good. Yeah, because I don't think we answered, or I answered all the questions that were asked. So,
No, not. It'll be sent to you via me. Thank you once more.
No, thank you. All right.
Yeah, we're grateful.
Okay.
So have a nice day. Bye. And bye,
And you,
everyone.
Christian. Thank you. Yep. Take care.
You're welcome.